Okay, in Calculus 1, at the beginning of Calculus 1, before you get to L'Hopital's rule, you do quite a few limits. And the interesting thing about this one is that it's not a rational function. And x is going to negative infinity. For a rational function, it would be very easy to do. We have a process for doing that. And we're going to use a similar procedure here. Okay, the square root of x squared plus x over 4x plus 3 as x heads to negative infinity. But I want to show you something first. If we have the square root of 5 over 2, and we want to get that 2 into the radical, we could do this, divided by the square root of 2 squared, couldn't we? And, of course, this is 2, right? But then we have the square root of a over the square root of b, and as long as all roots exist, then we have 5 over 2 squared. And I got the 2 inside the radical. Of course, it's the square root of 5. Oh, sorry. Bigger bracket. Square root of 5 over 4. And that's a nice trick, and you can bring things into radical that way if you want to. All right. This is a nice little technique, and we're going to misuse this technique. And you're going to see why. And we're going to make the freshman error, the error that most students make when they try to do one of these, find the limit of a algebraic function. Right? So, I've got some students coming. You can watch this. I'm filming this. That's all. I just want to get a film of this. So, what's the typical thing you're going to do? I'm just going to work with the expression and take the limit out just to see how we can simplify this expression a bit. And what's the trick? The normal trick is this. You divide the top and the bottom by the highest power in the bottom. So I'm going to put x, it's highest power in the bottom, right? And I'm going to take 4x plus 3, because we know we can divide a fraction, the top and bottom of a fraction by the same number, and it doesn't change the fraction. So that's not too bad. And then I'm going to use this trick. I'm going to bring the x into the radical, and the way I do that is I call it the square root of x squared. My phone's ringing now. That's going to have to ring out. Okay, so I'm going to bring it into the, and we'll have this, right? Because we'll change this to the square root of x squared, right? And then we'll have a radical over radical, and it end up looking like this. Then we'll have a radical over radical, exactly what I want to say, x squared plus x over x squared, right? And that's going to be over 4x plus 3 over x. 3 over x. I'll make sure I copied everything right. Now we can simplify this. I can split this into 2 fractions. That's the typical system. And then you can take limits. And I'll split this into 2 fractions and simplify, and then I can take more limits, right? Okay, so the only problem is you'll get the wrong answer. And here's the reason. The square root of x squared does not, I'll put it over here, I'm sorry. No, you're not going to see it if I don't. The square root of x squared does not equal x. It equals the square root of x squared equals the absolute value of x. And we have to divide the top and the bottom by the same expression. And we did. We divided this one really. And this does not really equal this at all. It doesn't equal that at all. We divided the top by the absolute value of x, really, and the bottom by x. So we have to go back and redo it. I'm going to have to divide the top and the bottom by the square root of x squared. And that will give me the right answer, because I'm actually doing it right mathematically. Okay, so this doesn't equal this. But let's see what I can do to fix this. Let's go over here and divide this by the square root of x squared. The square root of x squared. Okay? Now I'm dividing the top and bottom by the same thing. Okay. So now I can say this is the square root of x squared plus x divided by x squared. All right? And this is 4x plus 3 divided by the square root of x squared. Okay, we'll leave it like that. Now I can start doing some simplification. So I'm going to split this fraction up. And this is the square root of x squared over x plus, over x squared, sorry, plus x over x squared divided by 4x over the square root of x squared plus 3 over the square root of x squared. Okay, now let's see what I can do with that. This is 1, isn't it? And this is 1 over x. So this equals the square root of 1 plus 1 over x. Okay, at the bottom, 4x over, well, we can't really reduce it yet. The square root of, you have to remember that the square root of x squared is the absolute value of x, right? The absolute value of x. Plus 3 over the absolute value of x. Now we're almost there. We've almost got it simplified, but I don't like absolute values. I can't reduce this with absolute value. Okay, I can't do anything with that. So, but I know this, that the absolute value of x equals x if x is greater than or equal to 0, and negative x if x is less than 0. Well, we're going to negative infinity, aren't we? So it's negative x, isn't it? It's going to be negative. We're only going to put negative values in, bigger and bigger negative values, right? So I can just put negative x here and negative x here. And I'm going to, if you want, write this down. This says that, this is the definition of the absolute value, which is the square root of x squared, or this. All right? So I'm going to finally get this simplified. And it's going to be the square root of 1 plus 1 over x over 4x over negative x. And I'll bring the minus up front here. This is negative x also, minus 3 over x. Over x. So here's the negative x here. I could bring that out in front. I'll just leave it there, though. And I just brought that out in front. Okay. Now this simplifies nicely. This will give me my final... Why don't I just put it right up here? The limit, okay, as x heads to negative infinity of, in other words, this is going to be the same expression as this, the square root of, I'm going to make that bigger because I want to make sure you can see this whole thing here, right? The limit, okay, as x heads to negative infinity of the square root of 1 plus 1 over x over, well, if I reduce this is negative 4, isn't it? And this is minus 3 over x. Okay. So I took this, of course, this reduces to the x's cancel, and you're left with a negative still. Negative 1. If I had brought the negative out here, it would just be negative 4. Now, let's take the limit, okay? Let's get rid of this. You can always stop and copy stuff. I know I erase a lot, but you can always stop and copy stuff. And let's see what we have here. We have the square root of 1. Of course, as x gets huge in the positive or negative direction, this guy's going to 0, right? We know what 1 over x looks like. Plus 0 divided by negative 4. And as x gets huge, right, this goes to 0. So 4 minus 0, if you want to put it that way. And of course, the square root of 1 is 1. This is negative 4. And so it goes to negative 1/4. So this function gets closer and closer to negative 1/4. Had you made the error that I showed you originally, by just putting the x in there and not really dividing by the square root of x squared, and understanding that that's the absolute value of x, you would have ended up with positive 1/4.